We'll proceed on pseudo multivariable calculus. Pseudo multivariable calculus, the area in which we are pursuing the discussion. Pseudo multivariate calculus is a concept where we start our solving our problem in mathematics through simple mathematical formula. Simple mathematical formula leads toward multiplication of two items, addition of two items, addition of two items, division of two items, or subtraction of two items. This is called basic mathematics. This is called basic mathematics. We start solving our problem through basic mathematics, and then finally we will end up with vector and calculus. So that is concept of pseudo. Pseudo means write code in an abstract manner and then in a simple manner, and later you see the magic. Anyway, in pseudo multivariable calculus, we will proceed upon the calculating the surface area of a sphere. Okay, so do you have a sphere? So I had a sphere. I believe a sphere is with me, or I have a better sphere. Okay, I'll have different sphere. Okay, consider this. I have a sphere. It is very heavy. Okay, I have this sphere. I'll take another one. Okay, so this is lightweight. This generally I take. So I have a sphere. Calculate the surface area of the sphere. That is a question. Now, whenever we talk about surface area means it has two sides. That is called area. Okay, that is called area. Area which has two sides. Okay, surface area. Area means which has two sides. Volume means which has three sides. A line which has only one side. So if I'm talking about area of anything, then it has two sides. Anyway, what is the approach that we take calculating the surface area of a sphere? Surface area of any item, it has two sides as per the pseudo multivariable calculus. We are talking about pseudo. Can we write pseudo code? Anyone, if I ask, can you calculate the surface area of a sphere? Can you calculate? I am 100% sure that he would start sweating. What is surface area? I don't. What is surface area of this? Okay. Can you find surface area of this? Yes, yes, I can find surface area of this. That is width into height. Okay, that is that is width into height is surface area. Then write it. This is called pseudo mathematics. Whatever problem someone is saying, facing, that problem now represent into simplest manner. If I'm trying to calculate surface area of this curved region, take a flat region and then calculate the surface area. This is A and this is B. A into B is the surface area. Okay, this is A, this is B. Makes sense? Now consider this is not a rectangle. Now this is the simplest case to find the surface area. That is a rectangle. Now let's twist it. I cannot twist it, but consider that twist it. If I twist it, then consider it becomes a parallelogram. Okay, so this is a rectangle. How we proceed in solving a problem? That is what we are talking. So when we are proceeding solving a problem, then consider this is a rectangle. This is a rectangle. This is a rectangle. If I twist it, then this becomes a parallelogram. Now Next rectangle is parallelogram. How to calculate surface area? How to calculate surface area of a parallelogram? Okay, this is A and this is B. If it was a rectangle, if it was a rectangle, okay, if it was a rectangle, then calculating was easy. Base A into B. A into B is the surface area of a rectangle. When A is tilted, it is a parallelogram. Then what is the surface area of A into B? Then it will be A vector cross product with VB vector will give the surface area. Can you please purify it? Okay, consider this is origin. Consider this is origin. And this point is x1, y1. This point is x2, y2. What is this vector? This is xi plus yj. I'm sorry, x1i plus y1j. This vector is x2i plus y2j. This being origin, that's the bottom left corner. What is area of this parallelogram? Area of this parallelogram is x1i plus y1j cross product with x2i y2j. Whatever comes, calculate the magnitude of cross product of two vectors will lead into third vector, and third vector will give the direction of the area. What is direction of the area? Direction of the area is, if this is the section of the surface area. If this is the surface, if this is the surface, then surface area is this. Surface area vector is this. If this is the surface area vector is perpendicular to the surface. So that direction will be the cross product vector direction. Magnitude will give the surface area. Funny, right? If I cross A cross B, whatever the new vector comes, if I calculate the magnitude of it, it will give the area of the parallelogram. Whereas if I take the unit vector of that, the direction will show a perpendicular vector that is coming out of the surface. I believe it is all right. So that is called the area vector. So if I now I come back to same problem again. What is the area of this rectangle? Area of rectangle, earlier it was A into B. Now it is A vector. A vector means if this corner is 0, this is x1 y1, this is x2 y2, then x1i plus y1j cross product with x2i plus y2j, x1i plus y1j. Y1 is 0 because it is pure x-axis. x2i plus y2j. x2 is 0 because that is pure y-axis. Now it becomes now x1i cross product with y2j. x1 x1 into y2 k vector whose magnitude is x1 into y2, width into height. Simple. Okay, if it is a parallelogram, then first one is x1i plus y1j, where y1 is 0. x1i cross product with x2i and y2j, where x2 is there and y2 is there. Makes sense? So this is typically called calculation of the area vector. Oh, understood, understood. Okay, thank you very much. Can you apply the same thing that you were calculating the surface area of a sphere? Now, a sphere has this curved surface. Can you see? Now we calculated for the flat surface and surface area of the curved surface we want, whatever it is. Any moment, if I take a small strip out here, then as per the surface, there will be, if there is a small strip I take, then there will be two sides, one side and another side. Okay, in that sense, if I watch it carefully, okay, so in two sides, okay, so in In two sides, if I watch it carefully, then any point if I take on the surface, this point is x comma y comma z. X comma y comma z. If I see from the top, then x comma y is the intersection. From there, any point on the surface, if I take the point, that point is x comma y comma z. Okay, if I draw a vertical line from that point, it hit here on the surface. This point is x comma y, whereas the height is z. That is x comma y comma z, whatever it is. Now, idea is I have to find the surface at any moment x comma y comma z as cross product of two vectors. This is what is pending now, because we understood through pseudo mathematics, if I take cross product of two vector, then cross product of two vector, then I get the kind of surface area. Anyway, now in that sense, what these two vector will be? Okay, the two vector. Let's see the how many planes we have. How many planes? Okay, if I go back again, there can be many ways someone can find the surface area of the sphere. I'm not saying this is the only one way, but this is the sphere surface area. There is a plane called XY plane. There is a plane called YZ. I'm sorry, this is X axis, this is Y axis, and this is Z axis. In that sense, this plane is called XZ plane, and this plane is called YZ plane. This plane is called XY plane. Okay, in that sense, now if someone remembers well, then we brought a concept of a length vector. There is something called length vector. What is a length vector? Length vector means what is the length of this curve? What is the length of this curve? Okay, length of this curve, if I'm trying to calculate, consider this is x-axis. Then there is a curve with equation is y equal to fx, function over x. This is a curve. What is the length of this curve from origin to any point x comma y? Now we will go again for a pseudo mathematics, and we will go for the simplest case where it is a straight line. What is the length of a straight line from point origin to point x comma y? Then it is represent it as a vector and calculate the magnitude. Vector representation of a line that is from origin to point x comma y is xi plus yj. Okay, now if we see a straight line, if I see a straight line, if we see curve line, the difference between them is curve line y by x, y by x, y by x, everywhere it is different. Whereas if it is a straight line, then y by x, y by x, y by x is same. In that sense, I have to represent our xi plus yj vector, because if I take origin and connect it to point x comma y, if I take origin and connect it to point x comma y, then this straight line vector, if I calculate the magnitude of it, it will give the length of the line that is from 0 to x comma y, that is xi plus yj. Its magnitude is x square plus y square root. Okay, if that is the scenario, then I have to represent into y by x, because y by x is variable from, and it is different for a case where it is a straight line, or a curved line. Then I can take out x and it becomes I plus y by x j bracket close into x. Now the division I'll represent as differentiation and multiplication as integration. It becomes I plus dy by dx j bracket close into dx, where dx limit is from x1 to x2. Now here if I'm trying to calculate the length of this line from origin to x comma y, then integration is x is 0 to any x. Anyway, this is called length vector. If I have any line, then I can represent it as a length vector, that is I plus dy by dx j bracket close into dx. Anyway, now to find, now To find the surface area of this, I need to find two vectors. I need to find two vectors. What two vector I can get for any surface area here? Two vectors. I can cut it two perpendicular lines. I'll get two vectors. Okay, if there is a surface, consider this is the surface. If I take out this is the surface now. If this is the surface, if this is the surface, then if this is the surface, then it is combination of this curved line and this curved line. Makes sense? If this is the curved surface, if this is a flat surface, then it is this is one line and this is another line. That is the flat surface two line. If I do cross product of this line and this line vector, it gives me the surface area of this. If this is a curve, then if I take cross product of this vector again, this becomes curve now. But vector can be represented for curve also. Again, this vector cross product of this curve vector will give the surface area of this curved surface. Flat surface, this vector cross product this vector. Curved surface, again this vector cross product of this vector. Because the curved surface, the line can be represented in a vector again. That is algebraic vector, and that is I plus dy by dx j into dx. This is the vector representation of a curved line. I plus dy by dxj. Actually, it is xi plus yj. That is the vector. Now I have to bring y by x from it, because for curved line y by x is variable. In that sense, it becomes I plus y by xj into x. This is the representation of a line, curved line. Now y by x will become dy by dx and into x will become dx. Now I believe it is very straightforward. If I need to calculate the surface area of this flat line, then this vector cross product with this vector. I'm sorry, if I take this as origin, then this vector cross product this vector. If I make it a curve, then this curve line, now this straight line vector become a curve line vector, and this curve line vector. Curve line vector and curve line vector cross product will give the net surface area. Makes sense? Now, how to get this curved surface? Curved surface I can get if I bisect this in z plane. This height is z because surface is in z. Surface constitutes z. Then it has x and y, but main is z. To get the surface, okay, if this is, consider this is xy plane. Consider this is xy plane. So this is a surface that is kept on xy plane. It does not have any height. Okay, but if I start giving z value, then this surface will come which will have a z. Okay, now consider this surface. This surface is a surface which has a surface. It has, I'm sorry. Okay, so how I can demonstrate it? Okay, let's start with the bigger thing. Okay, if there is a surface like this and it has a z value and there is a surface, I have, what is the idea here? Idea is that I have to take out two curved line to which I do the cross product and I get the surface area. That is the concept. This is not the flat surface. This is a curved surface. If it is a curved surface, if I take any section of the curved surface, if I take any section of the curved surface, since it is an area, it will have two end. Like this is the flat surface and it is a curved surface. It has two lines at two ends. Okay, how I can take the curved surface? One idea is that cut it into xz plane, cut it into yz plane. We will see things more later. Understandable? Okay, if this is the idea is I have to take out a curved surface, small curved surface region for which there will be two curved line that will be towards its boundary, and I have to take cross product of two curved line. I know the curved line how it can be represented in vector. The cross product of these two will give the curved line. How to take out that surface? Now the idea is that surface, what I take out, one side will be in exactly in one plane, one vertical plane, and another side, if I cut, it will be in another vertical plane. It may not be one plane and another plane. They make 90-degree, not required that they make 90-degree only. I can that we will see. That is the concept. Anyway, now let's cut this. Let's cut this. This explanation is not available in any of the book. Anyone can try. Whatever we are talking, that calculating the surface area through the cross product of two vectors and through the pseudo mathematics, it is not available in any of the book. Anyone can try. Now let's cut it in xz plane, cut it in yz plane. If I cut in xz plane, then it will reach that surface area I'm talking. If I cut any point, consider this point I am taking. This point, if I cut in xz plane, and this point I cut in yz plane. If I cut in xz plane, there will be a curved line. Rather, there will be a circular line if it is a sphere like this. If I cut in YZ plane, there will be a circular line like this. One circular line like this and one circular line like this. I believe it makes sense. Okay, if I cut in XZ plane, consider this was the point on the surface point. At that point, I make a cut in XZ plane. It will resolve into a circle where this point is there. When I cut in YZ plane, then it will resolve into another circle with point here. Here. If I cut in XZ plane, it will be a circle, and yz plane it will be a circle. Now I have a surface which has two sides, one side in xz plane and another side in yz plane. I believe it is all right. Now xz plane circle, if I know vector form, and yz plane circle, if I know vector form, then calculating the cross product of these two will give the surface area of the curved region. I believe it is all right. Now, xz plane, if I take, consider I cut in xz plane where y is 0, and I cut in yz plane where x is 0. Now, in that sense, what is the equation of the curved line in xz plane? If I had xy plane, if you remember well, little time back, we talked, if I have xy plane, this is x axis and this is y axis, and I have a curved line, then the length vector is I plus dy by dx j bracket goes into dx. Similarly, if I have a line in xz plane, it will be I plus dz by dx k into dx. If I cut in yz plane, then it will be j plus dz by dy k into dy. Now cross product of these two will give the area vector. So area vector is I plus dy by dx. I'm sorry, I plus dz by dx k into dx cross product j plus dz by dy dy k dy. If I do cross product of these two, it becomes minus dz by dx minus dz by dx I minus dz by dy j plus k dx dy. This is called area vector. Now, I calculated the area vector at any moment for a generic xyz. That area vector is perpendicular at that point. If this is the surface area vector, every moment it will be perpendicular at that time, because this is the inherent nature of cross product. If area vector I took and two sides, one side is xz plane and another side is yz plane, then that is the surface area. Surface area vector will be a vector that will be perpendicular to the surface at any moment, whatever it is. We are not worrying about the surface area vector direction. We are worrying about the surface area magnitude. Anyway, now we cut it into xz plane and yz plane. Can I cut in a cake man? Like if I cut cake, then angle may not be 90-degree. There is a cake, and if I cut it like this and then like this, then angle in between may not be 90-degree. It may be 30-degree only. Can I cut like this? Like if I cut in any z, this is z I have to cut certainly because the surface area has z value. So I cut like this and then I cut like this. Earlier I am cutting in xz plane and yz plane, completely 90 degree to each other. There are three planes only, xz plane, yz plane, xy plane, that are orthogonal to each other. When I cut it any z and any arbitrary, and then I cut in another z and any arbitrary where angle is 30 degree, then it will take out a kind of a surface area. Makes sense? But that will not be a rectangular surface area. That will be a parallelogramic surface area. Makes sense? Please mind it. If I'm cutting like this, I'm so sorry. If I'm cutting like this, okay, if I cut in xz plane and yz plane, it will come as a rectangular come surface area where if I take this curve, then it will be in xz plane and this curve will be in yz plane. That is kind of a plane is 90 degree to each other. But if I cut z and any axis and z and any axis where angle is not 90 degree between them, between two planes, I take any plane which has z and anything. So if this is okay, this is x axis and this is y axis. Okay, this is xy plane. Now, in that sense, earlier I was cutting, this is z. I was cutting one is xz plane and one is yz plane. Like I'm cutting one in z and along this angle, and I'm cutting another one z and this angle where the angle is not 90 degree. Earlier we are cutting in xz plane and cutting in yz plane. Now I'm cutting in z and some alpha plane. We consider this vector as alpha. This is x-axis I vector. This is j vector. Consider this is alpha unit vector. I am cutting in z alpha plane and this is beta unit vector. I am cutting in z beta plane. Can I do like that? You can do like that. No one is stopping you. Then it will the surface area what I receive after cutting it. It is one in z alpha plane and one is z beta plane. Okay, there I can do cross product again. Okay, but it will be difficult to solve. Now you have to find the it will be again a curve vector and this alpha z plane again there will be a curve vector. So alpha z plane there will be a curve vector. Okay, earlier this was xz plane, there is a curve vector, and yz plane there is a curve vector. Now alpha z plane curve vector and beta z plane again a curve vector. Now this curve vector and this curve vector. Okay, these two curve vector, if I do cross product, more or less it will give the area of a surface that will be parallelogram in the nature. All right, we can do, but I have to first find the this falls in z axis and this I don't know alpha angle. Earlier, it straightforward fell in Z and I, K vector and I vector. I took this vector directly as I plus dz by dx, I plus dz by dz by dx, K into dx. Now here I have to take now, instead of I, it will be alpha unit vector. Alpha unit vector plus dz by d alpha k vector into d alpha. Makes sense? Now, if I take like this, then beta unit vector plus dz by d beta k vector d beta. Now, I have to do cross product of these two. Now, it will come as whatever it comes. Someone can try. At the end, it will come as d alpha d beta. Now, alpha is from where to where and beta is from where to where. Somewhere this can be taken as an assignment that someone can try bisecting it as 45 degree from the xy if this is x, if this is x and this is y. To make it simple, I can take alpha as 45 degree from x axis and beta is from 45 degree from y axis. Now again it will be orthogonal only but simpler. Now in that sense someone can calculate. Now alpha, now for the sphere, alpha will go from one end to another end and beta will go one end to another end. From now, if I take a surface area of a sphere in x axis, then x is from minus a to a. Very straightforward. Okay, because now I have to, if it is dx dy, then x has a length and y has a length. Understandable, right? In multiplication, I have now minus dz by dxi minus dz by d, or rather d minus dz by dx minus I plus dz by dy minus j plus k bracket close dx dy. Dx dy is x into y. X has some length and y has some length. That I place at dx dy. They will come as a limit. What is x limit and what is y limit? Now that I have to see when I look from the top of the sphere. Okay, so if this is the sphere, if I look from the top of the sphere, then on the xy plane it will form a circle where x is from minus a to a and y is minus a to a. But since it is a circle, x, y are related to each other. They are not independent to each other. In that sense, x is minus a to a, then y is minus square root of x square minus, I'm sorry, minus square root of a square minus x square to square plus square root of a square minus x square. That is the limit. Now the full expression for the surface area is magnitude of minus dz by dxi minus dz by dyj plus k dx dy, where y is minus square root of a square minus x square to square root of a square minus x square, and x is minus a to a. If someone takes in alpha and beta, then he has to take limit accordingly. Okay, it cannot be minus a to a. Okay, because it has to be placed in x and y. It will be tedious. That's why we cut in xz plane so that computation will be straightforward. Anyway, if that is the scenario, what is magnitude of dz by dxi minus dz by dyj plus k? It will come at dz by dx whole square plus dz by dy whole square plus 1 square root dx dy, and then the limit. Limit is circular region, okay, in xy plane. What is z? X square plus y square plus z square equal to a square. That is the equation of a sphere. That is z equal to square root of a square minus x square minus y square. Dz by dx whole square. That will come at x square by a square minus x square minus y square plus dz by dy whole square. That will come as y square by a square minus x square minus y square plus 1 square root. To settle down, it will become a by square root of a square minus x square minus y square dx dy, an integration in a circular region where x is minus a to a and y is minus square root of a square minus x square to square root of a square minus x square. A I can take outside 1 by square root of a square minus x square minus y square. Let's take y equal to a cos theta. I can take y equal to a cos, I'm sorry. Let's take y equal to square root of a square minus x square cos theta. Okay, y equal to square root of a square minus x square cos theta. In single method of substitution, I can take whatever I want. In multivariate method of substitution, I cannot take whatever I want. Yeah, I can take whatever I want for first one, for second one. Like I'm making method of substitution for I'm changing x and y both. In that sense, I have to go by some rule and regulation. I cannot do like that. But for single variable, I can do. So y equal to square root of a square minus x square cos theta. Dy equal to, this is constant, so it will become square root of a square minus x square minus sine theta. Okay, let's take y equal to square root of a square minus x square sine theta. So dy equal to square root of a square minus x square cos theta d theta, because dy equal to dy by d theta into d theta. In that sense, dy becomes the square root of a square minus x square cos theta d theta. Here, square root of a square minus x square is constant right now when we are integrating through dy. I can keep it outside. That is a into square root of a square minus x square. Now, integration of 1 by square root of a square minus x square. A square minus x square minus y square. Minus y square will become minus a square minus x square sine square theta. If someone settle it down, it becomes 1 by square root of a square minus x square root of 1 minus sine square theta, that is cos theta. Okay, that is cos theta. Now we have outside square root of a square minus x square, and here it is square root of a square minus x square. Okay, in that sense that will cut down. Cos theta cut down, nothing remains. Square root of a square minus x square cos theta will go away with the dy. Dy became square root of a square minus x square cos theta d theta. Full will go away. Only d theta dx remain there. Now d theta, if I do integration, it's become theta. Theta is from where to where? Now y is minus square root of a square minus x square. That is the limit. Now here we have y equal to square root of a square minus x square sine theta. Then theta equal to sine inverse y by square root of a square minus x square. If I keep lower limit, then it becomes sine inverse of minus 1. If I take upper limit, it becomes sine inverse of 1. That becomes minus pi by 2 to pi by 2. Theta minus pi by 2 to pi by 2, it will become pi. Pi by 2 plus pi by 2, it will become pi. So solved. Now pi and a I can keep outside. Pi a. Now only dx is there. I believe so. If there is something wrong, okay. Dx. Now integration of dx is x minus a to a. 2a. 2a pi a. 2 pi a square. Okay. Now we started with a sphere that was centered at the origin, and we took in xy, means we took about the top hemisphere multiplied by 2 will give the full, that is 4 pi a square. So 4 pi a square is the surface area of a sphere through the area vector. And area vector is nothing but that length vector cross product, and that length vector cross product, we started with the pseudo code cross product of the parallelogram. Cross product of two vector of the parallelogram gives the area, or the cross product of the two vector of the rectangle, or length into width. We started with the length into width, we give the area of a rectangle. 2 length vector into width vector give the area vector. 2 length vector, 2 xz and yz length vector, 2 cross product of this length vector, 2 calculating the magnitude of this length vector, 2 finish the problem. This is called pseudo multivariate calculus, where we start with the small thing, with basic mathematics of multiplication, and slowly we finish the job. Anyway, we will see more into it, like spherical coordinate system and then volume vector. So those things we will see. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.